Hello everyone, welcome back to my another new YouTube video. So in this video I'll be solving problems of module 1 and module 2 of basic electrical engineering subject from VTU module question paper 2. I have already solved VTU model question paper 1 in my previous videos. Those who have not seen that, you can refer it to my previous videos. The link will also be given in the description. So coming back to the VTU model question paper 2, I have solved problems of 1C, 2C, 3A and 3B, 3B as well as 4B from module 1 and module 2. Coming back to 1C, that is module 1 question. A resistor R is connected in series with the parallel circuit of 12 and 8 ohms. So 12 ohms and 8 ohms are connected in parallel. So 12 ohm, 8 ohm are connected in parallel. 8 ohm are connected in parallel. Now this is connected in series with the resistor, unknown resistor R, and the supply voltage is given as 20 volts. 20 volts is given, and the total power dissipated is 70 watts is already given. You need to find out what is the value of the unknown value R. Now you have the total power 70 watts, supply voltage is 20, so you can easily calculate what is the main current I. So main current I, you know that total power is equal to the supply voltage into the supply current. So total power dissipated is 70, 20 into I. Now that implies I will be equal to 70 by 20. You will get it as 3.5 amperes. So you got the main current as 3.5. So now this 3.5 amperes now get distributed between 12 ohm and 8 ohm, I1 and I2. Now this gets added up again, the same 3.5 ampere current will flow through the resistor R. Now this parallel combination and R are connected in series, so you will get a voltage drop V1 across the parallel combination and V2 drop across the unknown value of R. Now let us calculate what is the current I1. Now branch current I1 I can calculate as main current, that is 3.5, into resistance of other branch, that is 8, divided by sum of resistances 12 plus 8. So if you solve this, you are going to get the answer as 1.4 ampere. So I need not calculate I2 over here. The reason is I only need to calculate what is a voltage drop across the parallel combination. So I can calculate, therefore V1 will be now equal to I1 into the resistor 12 ohm. So that is equal to 1.4 into 12. So I'm going to get it as 16.8 volts as a voltage drop. So once I get the voltage drop here as 16.8, the same voltage drop will be there across 8 because 8 and 12 are connected in parallel. Now your voltage drop, therefore voltage drop V2 will be now equal to 20 minus V1. So this will be now equal to 3.2 volts if you substitute V1 as 16.8 volts. So you got to know that the voltage drop across R is 3.2 volts and the current flowing through R is 3.5 ampere. So I can easily calculate the unknown value resistor R will be equal to V2 divided by I. So that is equal to 3.2 divided by 3.5. You'll get the answer as 0.91428 ohms. So this is a value of the unknown resistor R. Coming to the second problem, two resistors are connected in parallel. So I connect two resistors in parallel. One as R1, I'll name it as R1, I'll name this as R2, and the parallel combination is connected to a 200 volt supply, DC supply. The total current taken is 2.5 amperes and the power dissipated in one of the resistor, let me name it as power across R1, dissipated across R1 is 1500 watt. They have asked what is the value of R1 and what is the value of R2. Now if you see that the total power dissipated, that is 200 into 2.5, you'll get it as 500 watt, but they have given that the power dissipated across one of the resistor is 1500 watts. Now this is not possible at all, so which means that there is some mistake in the data which is given. So you can take, instead of current 2.5, you can take it as 25 ampere. Now once you get the main current, now you can see that R1 and R2 are connected across a 200 volt supply and they are connected in parallel, which means that the voltage drop across both will remain the same, that is 200 volt. So I can calculate the value of power across R1 will be equal to voltage V square by R. So that is V square across R1 divided by R1. That implies 1500 is equal to 200 square divided by R1. That implies R1 will be equal to 26.6667 ohms. So this is a value of the first unknown resistor R1. Now how do we calculate R2? For that I need to calculate the branch current I1 and I2, so that I can easily calculate the value of R2. How do I calculate I1? You know that power is equal to power across R1 is equal to voltage across R1 into I1. You know that power across R1 is 1500, voltage across R1 is 200 into I1. That implies I1 will be equal to 7.5 ampere. So you'll get the value as 7.5 ampere. So once you calculate this, you're going to get I2 as the main current I minus I1. That implies 25 minus 7.5. You will get it as 17.5 ampere. So you got to know the value of I2. Once you got to know the value of I2, you know that voltage V across R2, that is equal to R2 into the current through R2, that is I2. So 200 is equal to R2 into 17.5. Now that implies if you solve this, you are going to get R2 as 11.4285 ohms. So this is the answer for R2. Coming to the module 2 question, a voltage of 125 volts, that is 3B, a voltage of 125 volt at 60 Hz is applied across a non-inductive resistor connected in series with the capacitor, which means that it is a RC network which is connected to a AC supply of 125 volts, 60 Hz AC supply. The current is 2.2 amperes. 2.2 amperes is RMS value of the current. The power loss in the resistor is 96.8 watts, and that in the capacitor is negligible. Okay, so calculate the resistance as well as capacitance is what they have given. So you need to calculate R as well as C. So let us write the given data. We know that VRMS is given, that is 125 volts. Frequency is 60 Hertz. Then current IRMS is equal to 2.2 amperes. So they have asked what is R and what is C. Now we can calculate from here. The power loss is given, that is 96.8 watts. We know that power is equal to VI cos phi. Power is equal to VI cos phi. They have told that the power in the capacitor, power loss in the capacitor is negligible, power loss in the resistor is 96.8. So the overall power loss is nothing but 96.8, that is equal to VRMS 125 into IRMS, that is 2.2 into cos phi. So now if you solve this, we are going to get cos phi is equal to 0.352. So that is the value of cos phi we have got. Now why do we require cos phi? Because in a RC circuit, again we know that cos phi is equal to R by Z. So if I calculate now cos phi as well as Z, I can easily calculate the value of R, and we can calculate the value of XC. Thereby you can calculate C. So once you calculate cos phi, you can calculate Z. Z we know that it is V by I, so VRMS by IRMS. So that is nothing but equal to 125 divided by 2.2. If you calculate, you are going to get Z as 56.818 ohms. So that is the value of Z what you are going to get. Now once you are going to get the value of Z, you know that therefore cos phi is equal to R by Z from the impedance triangle. So if you calculate, that implies your R will be equal to Z cos phi. So that is equal to 56.818 into 0.352. If you solve this, you are going to get the value of R as 19.999 ohms, so roughly around 20 ohms. So this is a value of R what you are going to get. So you know the value of Z, you know the value of R. You know that for a RC circuit, Z is equal to square root of R square plus XC square. That implies so Z square 56.818 square is equal to 20 square plus XC square. Now that implies if you solve for XC, you are going to get XC as 53.1816 ohms. So once you calculate the value of XC, you know that xc is equal to 1 over 2 pi fc or omega c. So substitute this. So that implies 53.1816 is equal to 1 divided by 2 pi, f is given 60 hertz, into c. So if you cross multiply and get the answer, you are going to get the value of c as 49.877 microfarad. So this is a value what you have to get for the value of the unknown capacitor c. So this is how you solve the problem for 3b. Coming to the 4b question, which is related to parallel AC circuit and a complex problem. Two circuits, the impedances of which given are Z1 is equal to 10 plus J15 and are connected in parallel. So I have two impedances. So Z1 equal to 10 plus J15, which means that it is an RL circuit. And one more circuit you have, that is 6 minus J8, which is Z2, 6 minus J8, which means that it is an RC circuit which is of the form R minus JXC, and Z1 is of the form R plus JXL. So it is directly given in J term, so you need not worry about it. So Z1 and Z2 are connected in parallel. If the total current supplied is 15 ampere, what is the power taken by each branch, which means that what is the power taken by PZ1 and what is the power taken by PZ2 is what they have asked. Now this is very simple, like you know how you apply in a DC circuit, how you calculate the branch current. So let me consider this as I1, this as I2. You can calculate I1 as main current, that is 15 at an angle 0, into impedance of other branch, that is 6 minus J8, divided by sum of impedances, that is 10 plus J15 into 6 minus J8, sorry, plus J8, plus 6 minus J8. It is something like I1 is equal to I into, it is, now this is something like this. If you want me to write a general formula, it is branch current I1 is equal to main current into impedance of other branch divided by sum of impedances. So similarly I2 will also be the same, I into Z1 divided by Z1 plus Z2. Now if you are solving for I1 using complex numbers, you are going to get I1 as 15.4839 at an angle of 32.6806 degrees ampere. So this is a value of the current what you are going to get. Now how are you calculating I2? You already know I as 15 ampere. So I2 will be now equal to I minus I1. So it is 15 at an angle 0 minus 15 point, sorry, the value of I1 is different. So the value of I1 as 8.58899 at an angle of minus 76.7594 degree ampere. So this is a value of I1 what you are getting. I2 you can calculate using I minus I1, that is 15 at an angle 0 minus 8.58899 at an angle of minus 76.7594. So if you are solving this, you are going to get the value of I2 as 15.4839 at an angle of 32.6806 degree ampere. So this is a value of I1 and I2 you have got. But you to calculate the power across both the impedances, you know that it is VI cos phi. You need to know the voltage. Current is already calculated. You need to know what is cos phi. So for that, first we will find what is a voltage. So voltage V will be, you can be written as V is equal to I1 into Z1. You can also write V is equal to I2 into Z2. Both are same. The reason is both the circuits are connected in parallel. So it will be 8.58899 at an angle minus 76.7594 and into the first impedance, that is 10 plus J15. 10 plus J15. Now if you solve for this, you are going to get the supply voltage as 154.8566 at an angle of minus 20.4494. So these are the parameters which you have calculated now. That is one is I1 you have calculated, I2 you have calculated, V you have calculated. Now you need to calculate what is the power. You know that we know that power is equal to Vi cos phi. Now what is that we need to calculate now over here? Cos phi. Phi is nothing but the angle between the corresponding voltage as well as current. Now if we are calculating the power across, that is Z1, I need to calculate what is the voltage across Z1. It is same as the supply voltage because both are connected in parallel. The current through Z1, the current through Z1 is I1. I need to calculate what is phi. Phi is nothing but the angle between V as well as I1. For that, it is very simple to use a phasor diagram. Phasor diagram will always be helpful for calculating the power factor. So you have this reference. Voltage, the main supply current is given as 15 at an angle 0. So you have this magnitude 15. There is no phase. That is the reason why it is in line, that is in phase with the reference line. So it is 15 at an angle 0, which is 15 ampere. That is nothing but your I. Now it is voltage V, which is 154.85 volt at an angle of minus 20, which means that your voltage V will be 154.8 volts at an angle of 20.4494 degrees. Now the current I1 as 8.558 at an angle minus 76. So you have this current now. That is 8 ampere. So 8 ampere. So this is your I1, 8.588 ampere with at an angle of 76.7594. So 76.7594 degrees, and I2 as plus 32 and 15 ampere. So you have this I2 as 15.48 ampere at an angle of 32.6806. So this is a phasor diagram. Now what is the thing you need over here? It is angle between V as well as I1. So what is the angle between V and I1? You see here, this is V, this is your I1. I need the angle. So angle between V and I1, which is nothing but your 76.7594 minus 20 will give me the angle between V and I1. So you have to write cos of 76.7594 minus 20.4494. So I hope you have understood how we are solving here. So you need to write only the magnitude. So 154.8566 into current I1 is nothing but 8.58899 into cos of the same thing, the same angle, 76.7594 minus 20.4494. So you will get the answer PZ1 as 737.7842 watts. Similarly, I need to calculate what is the angle between V and I2. Now V is 76 and I2 is 15.8. Now the angle between the voltage V is nothing but 20.4494 and the current I2 is 15.48. So your total angle will be the addition of the voltage as well as the angle of the voltage and current. So you are going to calculate, sorry. Okay. So coming back to this, so I need to calculate what is the angle between the voltage and current I2. It is the addition of the angles of voltage as well as the current I2. So your PZ2 will be equal to V into I2 cos of angle between V and I2. The angle between V and I2 is 32.68 6 plus 20.4494. I hope you understood why it is plus, and in the previous case it is minus. So if you solve this, so it is nothing but 154.8566 into the current I2. I2 current is nothing but 15.4839. 15.4839 into cos of this angle, entire 32.6806 plus 20 angle. So if you solve this, you are going to get the answer as 1438.6738 watts. So this is, or 1.438 kilowatts. So this is how you are going to solve the problems related to parallel AC circuits. So this is all about problems from module 1 and module 2. Thank you for watching my video. If you like the video, please hit the like button, comment if there is any mistakes, and if you feel that any step I have gone wrong. And you can also share if you find this video might be useful for your friends. Thank you.